So before we begin our enzymes lab, we're going to do a demonstration lab, and I'm going to do it with you, that will walk you through how you would plot a standard curve to determine an unknown concentration of an enzyme, of a protein. In this case, we're going to use a dye, specifically bromophenol blue. So this dye is a colored dye. Of course, it's blue, and it will change how blue it is depending on what concentration it is. So what we can do is we can set up a standard curve by doing a series of dilutions of our dye. So we start out with a concentration of 20 microgram per mil of our dye, and we're going to dilute it from there so that we get a series of concentrations. Now, I've already used some of this data from some data that we had from a couple years ago. So I'm just going to kind of walk you through how you would actually plot a graph to generate a standard curve. And this is a very standard thing that you should probably know how to do. So I'm going to select only these last two columns from the big table that we set up in class. And these two columns are going to be the data that I'm going to use to plot my standard curve. And what I'll do is I'll hit Insert Chart. When I hit Insert Chart, I want you to realize something very obvious. Okay, so this is bromophenol blue, and what I want is a linear trend line. You can see that these points at the end are not linear. Okay, so what's happening is the dye is too concentrated up here and it's saturating. So you don't want to include these data points that are up here. So I'm not going to save this particular graph. I'm going to get out of there. And I'm going to go back and just select everything but the last 4 data points and to make my standard curve. This is also a benefit of doing more concentrations because you can get rid of ones that don't fit correctly. Okay? So I want to do a scatter plot. And I want to get a straight line. And now my line looks much more linear, which is good, which is what I want. Okay? But I'm not done yet because I've got to label my chart. So if I go under Chart and Axis Titles, I'm going to call this bromophenol blue. Standard curve. Okay? And I'm going to label all the axes. The horizontal axis is going to be concentration, and because the concentration is in microgram per mil, there's a trick that you can use to get this. I can just copy this information in there, and this is actually how I got it into the chart in the first place, or into the table in the first place, is by copying it in from the Google Doc. Okay, because unfortunately Google Sheets doesn't have quite the level of functionality that a Word document or a Google Doc would have. Okay, so now you have your horizontal axis title typed correctly, and your vertical axis title is absorbance at 590 nanometers. Okay, so now that you've got your concentration and your absorbance set up, we want to draw a linear trend line. In order to do this, we're going to select Series, and we're going to add a trend line. Okay, we also want to add the equation to the trend line, and this equation can be very useful. It will allow us to calculate the concentration of an unknown amount of dye or protein or whatever it is you're looking at. Okay, so now that our chart looks good and our equation looks good, we can now use this information to actually determine the concentration of an unknown. So if I drag this over here, you can see that my unknown from before was 1.2. That was the absorbance. Okay, so since I know the absorbance in this case is my y-axis. So this equation is actually, and I typed it over here, 0.0132x plus 0.0104 is equal to y. Okay, then we can take and manipulate our equation to solve for x. Okay, so when I'm solving for x, I'm going to add in my value for y. So my value for y is 1.2, and I'm going to subtract my y-intercept from it first. Remember, always do order of operations. And then I'm going to divide. So when you set up your equation the way it should be, you're going to have x equals, and make sure to put the parentheses, 1.2 minus your y-intercept divided by the slope. Okay? So if you type this in, which is what I did, and hit equals, you got to type equals first. Okay? So you would literally just hit equals, put a parentheses, type 1.2, subtract 0.0104, close the parentheses, and then divide by 0.0132. You can solve for what x is. In this case, our concentration of our unknown is about 90 microgram per mil. Okay? And then we could answer our question based upon that. So what I'm going to show you to do now is I want you to copy all of these things into your spreadsheet file, or sorry, into the information for the background materials. So what I'm going to do is, if you wanted to copy the table in, you just get Control-C, okay, and then you can go into your spectroscopy file and you can add the table, and you can also add the graph. You can even add the information that you use to calculate the concentration of your unknown just by selecting it. Okay? So now this is how you're going to set up just about everything in your enzymes lab. So we're going to switch to the second part, which is determining the standard concentration of the enzyme extract that we want to use. So in order to do that, I'm going to go back to my spreadsheet file from Google Sheets, and I'm going to go down to here. Okay? In the Google Sheets file, I have already set up a table with time and then 3 different concentrations of extract, similar to what you will do in lab. However, my data will not be the same as yours, and so please do not use mine to plot your graphs. Your extract will be different than mine. So select your data and go under Insert, Chart. Of course, it doesn't select the correct chart, so we're going to go down and select Scatter. And what we're trying to do here is actually determine the best concentration for our enzyme that will give us a linear graph, and will also a linear trend line, and will also give us absorbance readings that are in a good range. Okay, so I'm going to call this absorbance at 470 nanometers. Oop. Okay, that's my vertical axis title. My horizontal axis title is time in seconds. And my chart title, okay, is standardization of enzyme extract. Okay. Peroxidase extract. Okay, so this is my first title, or my first chart, but I'm not quite done because I also want to go to series and I want to add trend lines. And I want to add the equation so that I can see just what I'm looking at. Okay? If you go under Apply to each one of these in turn, you can scroll down, select on Use Equation and R squared, and it will tell you how good your line is. Okay? Remember that we want this in the linear range, and we want our numbers to be a good level of absorbance, but not too high. Okay? So if we do this for each one of these, you can look at the equations and you can see what makes the most sense for us to use going forward. Okay? And I am changing the shape for each one of these so that if I wanted to print this document, I could tell the difference between the 0.5 mil, the 1 mil, and the 2 mil without the colors. Okay, so that's why I do this, and I will do this throughout. And you can see very, very readily that the best linear graph with the best absorbance range is definitely the 1 mil extract. Now we will do this for our graph because if we don't do this for our graph, we don't know if our graph is correct or not. In other words, we don't know if our standardization for our extract is the same as the standardization for the graph that we just did. Okay. Sure why this is not picking up the, maybe it's this one. Sorry. Okay. So standardizing enzyme extract, it's right here. Okay. So you can see that the 1 ml extract looks like our best choice from now on. Okay. And you will do this in order to determine what concentration of enzyme extract we want to use from that point on. And now we will move to the actual enzyme graphs.